Now we're going to do some drawing. Remember that the two kinds of models that we've learned how to make are called Bohr models and dot structures. The Bohr model will show all of the electrons in the element, while the dot structure will show only the valence electrons. Let's begin with carbon. In a carbon atom, remember that we'll write the symbol at the center, and then we'll put the number of protons. It's hard for me to get this exactly right on my screen, so we'll do the best that we can. Carbon has 6 protons. Its atomic number is 6. We'll draw a circle around that to represent the nucleus. If there are 6 protons, that means there are also 6 electrons. The first 2 electrons will go in our first energy level, so we'll draw electron 1 and electron 2 next to it. We have 4 remaining electrons, so we will draw a second energy level. And these electrons, remember to place them around the sides. So the first one goes here, the second one here, the third one here, and the fourth one here. We'll now stop and count one more time. I see 1, 2, 3, 4, 5, 6 electrons total, which matches the number of protons, so we know that we're done. Our dot structure will simply have the letter C, and then our 4 valence electrons, one at the top and one on each side. Make sure that your valence electrons match the dot structure exactly. Next, let's look at lithium. Lithium is a little bit of a smaller element. Lithium has only 3 protons, which means it only also has 3 electrons. So we'll start with our first energy level, where our first electrons, numbers 1 and 2, belong. Then we'll move to our next energy level, our second level, but our second energy level will only have 1 electron, which means that when we move down to our dot structure, we'll include our symbol for the element, the L, and the I. Again, remember to make sure that your second letter is always lowercase in your symbols. And then we'll draw the 1 valence electron up above. If you wanted to put this on the side instead of the top, that would be okay too. For sulfur, we need to make it a little bit smaller so that it's going to fit. Sulfur has 16 protons, which means it also has 16 electrons. Let's go ahead and draw our first energy level. This is our nucleus, and then energy level number 1. We're going to draw our first 2 electrons here, electrons 1 and 2. Then we'll draw our next energy level right around that. And this energy level is going to get up to 8 electrons. Since we have 16, we know we're going to use all the spots. Let's go ahead and fill them in the right order anyway, just because we need to be in the habit of doing so. So we have 6 total so far. This is number 7. This is number 8. This is number 9. This is number 10. That means we need to do one more circle outside of that. So let's do one more energy level. And we need to put our remaining 6 electrons here. We'll put 1 at the top. We'll put 1 on the right side, 1 at the bottom, 1 on the left side, 1 at the top, 1 on the right side, and that gives us all 16. If we stop and count, we have 2 here, 8 on the next level, that's 10, and then 12, 14, 15, 16. So we'll stop here. Then we go down to our dot structure. Well, we have an uppercase letter S. We have 2 dots at the top to match our valence electrons. We have 2 dots on the right-hand side, and then we have 1 single dot at the bottom and 1 single dot on the left. Finally, we have our fluorine atom. Fluorine is the element that has 9 protons, so we'll write our F, and then we'll write P equals 9. If you wanted to include neutrons in here as well, you can, but I won't hold you accountable for that on a test. Here's our nucleus, and then we'll put our first 2 electrons in our first energy level. So that's electrons 1 and 2. Then we'll draw our next energy level. This energy level will get electrons 3, 3 at the top, 4 at the side, 5 at the bottom, 6 over here, 7 at the top, 8 over here, and 1 down at the bottom for a total of 9, which means that when we go to do our dot structure, we will have 2 at the top, 2 on the right, 2 at the bottom, and 1 by itself over on the left. It's important that we get this right because as we move into Unit 4, we will be using dot structures quite frequently. Thinking about valence electrons, let's think of 2 ways to find how many valence electrons an atom has. The most common way that we've learned is to simply draw a Bohr model and count the electrons in the outermost level. We know how to do this for all elements up through number 20 on the periodic table. After that, the Bohr model rules change, and we haven't learned those rules yet. If you're trying to find the number of valence electrons for an element bigger than number 20, you can use a different rule which we learned in our gizmo. You can look to see which column the element is in. Remember, columns are also called groups. The atom will have the same valence electrons as all of the other elements in that column. So silicon will have the same number of valence electrons as carbon, for example. Tin, even though it's a metal, will also have the same number of valence electrons as carbon and silicon. Group numbers can be used also. If you look at the ones place, it will tell you how many valence electrons there are. So for groups 1 and 2, all of those elements have either 1 or 2 valence electrons. We'll skip the middle section because the rules are a little bit funny here. But for groups 13 through 18, these rules apply again. For group 13, there will be 3 valence electrons. For group 18, there will be 8 valence electrons. The only exception to those rules is helium, which only has 2 valence electrons. Let's think about how changing the particles would change the atom. If an atom of fluorine gained 1 electron, its charge would change. Because it now has more electrons than protons, it's now a negative ion. Its mass wouldn't change, though, because only protons and neutrons affect mass. Its identity would not change, it would still be fluorine. It would now be a negative ion of fluorine. If fluorine had gained a proton instead, which of course isn't possible, it would now be a positive ion because now it has more protons than it has electrons. Its mass would increase, and it would now be neon because it now has 10 protons, which changes the identity of the element. If it had gained a neutron instead, its charge wouldn't change at all because neutrons are negative. Its mass would increase, though. It would form a new isotope with a new mass number. But its identity would stay the same, it's still fluorine.